This is the first lesson on the entire unit on quadratic functions and equations, and there's a whole bunch of terminology and little things we need to cover in this first lesson so that you understand notations and terminologies that we're going to use throughout the whole unit. So the first thing we need to talk about is the concept of function. And it says a function is a special type of relation in which each element of the domain has exactly one element in the range. If any element of the domain is related to more than one element in the range, then the relation is not a function. So basically what it's saying is each x value can be associated with only one y value. So if we took something like x and y and we made a column, and we had 1, 2, 3, and we had y values of 2, 4, 6. This particular situation is a function because each x value has only one y value. If we make a second table, you'll notice here that the x value of 1 is associated with two different y values. So this is not a function, and I abbreviate function as fn, so if you ever see me write fn, that stands for function. So since we talk about functions, we also have something called function notation. Function notation is f bracket x, which is read as f of x. So if you see something written in function notation, it's going to have f of x equals 4x minus 8. That is the same thing as saying y equals 4x minus 8. It's just written in a different form, in a different notation. So anytime you see f of x, it means the same as y. And you're going to see in the next part of the situation here, it says if we write something in function notation, and we try to evaluate this function when x has a value of 5, that means everywhere there's a 5 in the particular equation, we're going to replace x with 5. Here, when we have a y equals, when it's written as y equals, all we do is replace the 1x with 5. But in each case, we get the same solution, y is being 12. So what this is really telling us is this is telling us that we have the point 5 and 12 on the graph of this particular function 4x minus 8. All right, so now we need to talk about something called the zeros of the function. Basically, the zero of the function is the value that makes the function equal to 0. So in this first question, when it says find the zero of the function, what we're trying to find is we're trying to find what value of x makes this function equal 0. So we're going to take 7x minus 21 and set it equal to 0 because we want to know when it's equal to 0. We're going to add 21 to the other side, and we're going to divide by 7, and we're going to get x is 3. So when they ask for the zero of the function, the 0 is 3. So like how we solved equations in the last unit and solved for values of x, those are also called zeros. Now, if you go to the next page, it says the graph of 2x minus 1 is shown over here on the right-hand side. It says determine the x-intercept of the graph graphically and algebraically. Well, if I look graphically, if I look at where the x-intercept is, the x-intercept is at 3. How else do I find the x-intercept in this particular situation? Well, what's the y value when you have an x-intercept? Well, the coordinate here is 3 and 0, so the y value is 0. So it's saying when y is 0, replace y with 0, solve for x, and we also get x to be 3. Now it says determine the root of the equation. Well, the root of the equation is determined by solving this particular equation, 2x minus 6 equals 0. Well, we just did this up here. We added 6, we divided by 2, and we got the root to be x equals 3. It says state the connection between the x-intercepts and the roots. So these are really important terms, x-intercepts and roots. X-intercepts and roots are the same. They're essentially synonyms for each other. If a question asks you to find the x-intercept, you find it. If it's asking you to find the root, you're doing the same thing. You're equating the function to 0 and you're solving for x. It says, what's the 0 of the function in part D? Well, remember, 0 is what's the value of x that makes this function 0? Well, 0 is the same thing also as roots and x-intercepts. So we have three terms that are the same. X-intercept, root or roots, and zeros. Those are all the same thing. So they're synonyms. They're words that we're going to use interchangeably. Anytime I or your workbook uses the word x-intercept, roots, or zeros, it means you're finding the x-intercept of the function. You need to know that. Okay, we're going to skip the next page. We're going to go to page 294. And at the top of page 294, we're going to summarize what we just talked about in terms of x-intercepts, roots, and zeros. So it says the zeros of the function, the x-intercepts of the graph, and the roots of the corresponding equation are the same numbers. So this is just a summary of what we were talking about in terms of roots, x-intercepts, and zeros, and how they're all the same thing. We're going to use a graph to also help illustrate that. If we look at this particular graph, this is the graph of a parabola. We're going to talk about these lots in this unit. It says, first of all, look at the x-intercepts. Well, if I look at the left-hand side here, if I actually even put a dot on it, my first x-intercept's at -2. My second x-intercept is at 3. And what's the y-intercept? Where does it cross the y-axis? Crosses the y-axis at -6. In the second part it says, what's the zeros? Well, the zeros are the same as the x-intercepts. They are -2 and 3. And in the third part it says, what are the roots of the equation? Well, they are also -2 and 3. This is illustrating what that definition is actually saying. So they're just terms that we need to know mean the same thing. So let's take a look a little bit at how we can actually use our graphing calculator to help us find zeros of an equation. The equation that we're going to work with is this equation up here, 2x squared minus 7x plus 3. So what we're going to have to do on our calculator is we're going to have to go to y equals. We're going to want to graph this equation. So we're going to type 2x squared minus 7x plus 3. And if I start going too fast with the calculator, just pause the video, catch up to where I am, and continue on. Now, next thing we're going to do is we're going to hit zoom and we're going to hit 6. We want to make sure that we have a graph of this particular function. So we do, in fact, you have a graph of this particular function. They want us to sketch this graph on our axis here. Well, if I look at that, it looks like my graph crosses the x-axis at about 3 and about a half. Looks like it has a y-intercept of about 3. So I'm just going to sketch to the best of my ability what this parabola looks like. Remember, a sketch is a quick representation of what that function looks like. It's not a completely accurate graph. It's just a quick situation. Now, we can actually find the x-intercepts on our calculator using a command on the calculator called the zero command. So where the zero command is actually located is you press second function and you press trace. You'll notice in blue letters is the word calc up here. That's exactly what we want to do. We want to calculate something on our graph. The second item in the menu is 0. So anytime they ask you to use your calculator to calculate an x-intercept, a root, or a zero, you're going to use this process. Now it asks you for the left bound. So essentially what they're asking you to do is, if you're trying to find this x-intercept on the left-hand side of your graph, they want you to move your cursor somewhere to the left of that x-intercept. And if you imagine that the x-intercept is here and you move somewhere to the left and then up to your graph, as long as your cursor is somewhere up here and to the left of your x-intercept, you're okay. How do you identify that point? You hit enter. So now it says right bound. Well, that means if you go from your x-intercept, you go to the right and you go down to your graph somewhere, that's going to be a right bound. So as long as you're down below the x-intercept somewhere, that's going to be your right bound, and you hit enter. Now it says guess. I hate this feature. Guess, if I wanted to guess the answer, I would have guessed a long time ago. No, I don't want to guess, so I just hit enter, and it tells me that the x-intercept, or the 0 in this case, is 0.5. Y has a value of 0 and x has a value of 0.5. So what we're going to do is, we're just going to write down our first x-intercept, which is 0.5 and 0. And now we're going to go back and we're going to find our second x-intercept, which is over here on the right-hand side. So we're going to press second function and trace, and we're going to choose number 2 for 0. Again, it wants a left bound. Now in this case, if you are to the left of the x-intercept, you are down below here somewhere. If you are to the right of the x-intercept, you are up here somewhere above the x-axis. So I'm going to move up here. Doesn't matter where, anywhere above the x-axis. When it says guess, we hit enter, and it does in fact tell us that the second x-intercept is 3 and 0. So that's what we get. Now, it says use the x-intercepts of the graph to factor this expression. Well, basically, what we're looking at is we're looking at the x-intercepts. We know x equals a half, and we know x equals 3. You never want to write your x-intercept as a decimal when you're converting it to a factor, because it makes it difficult to convert it to a factor. I'm going to start with x equals 3. If we're going to write a factor, we have to actually move the 3 over to the left side. So we have to subtract 3, and we get one of our factors to be x minus 3. Here, first thing we need to do is we need to multiply both sides by 2. So that's going to make this 2x, and when we multiply by 2 here, the 2's cancel out, and that gives me 1. Then I need to move the 1 over to the left side by subtracting 1, and I get 2x minus 1 and x minus 3 as my factors. And again, the zeros of the function are the same as the x-intercepts, so the zeros are 0.5 and 3. So that's not so difficult. Now, the big thing we want to be able to do is we want to be able to find the roots of our equation algebraically. And we actually did a little bit of that in the previous unit. Basically what you do is you factor this expression and then you solve for x. But before you can factor the expression, you have to actually set the expression equal to 0. So we need to subtract 33 and move it over to the left side. So now we're going to use the box method. We need two numbers that multiply to negative 33 and add to 8. Two numbers that multiply to negative 33 and add to 8. Oh, 11 and negative 3 works. So, take 11, we take negative 3, we divide by our leading coefficient of 1, and we get x plus 11 and x minus 3, and these are both still equal to 0. So to find the roots, we need to solve each of these factors. We need to take x plus 11 equals 0 and get x equals negative 11 as one of our roots. We need to take x minus 3 equals 0 and solve for x and get x equals 3 is a second root or a second x-intercept. Sometimes what they're going to do in a question is they're going to give you a question already in factored form. So to find the roots, you just equate everything to 0. In this case, 6 equals 0 doesn't make any sense. We start solving for x here, we subtract 5, and we divide by 4, and we get one of our x-intercepts, or one of our roots, to be negative 5/4. Here we add 3, and we get x equals 3 to be another root. Now, the next question says, find the zeros and find the y-intercept. Now, finding the zeros is just like finding the x-intercepts or finding the roots. The first thing we need to do is we need to take our equation and we need to set this equation equal to 0. Now, the first type of factoring you always want to try to do is you want to try to take out a common factor. In this case, we can take out a 5, and we're left with x squared plus 3x minus 4. So two numbers that multiply to negative 4 and add to 3 are positive 4 and negative 1. And if we equate each of these to 0, we get negative 4 and we get 1. 5 equals 0 doesn't make sense, so it's not part of our solution. So we have found the zeros. It also wants us to find the y-intercept. Well, if you think of a graph, if I just quickly plunk a graph down in front of you, if we try to find the y-intercept, the value of x at the y-intercept is 0, because a y-intercept has a coordinate of 0 and something. So what you do to find the y-intercept is you substitute x equals 0 into the equation. So in this case, if we take this particular equation here, we're going to have 0 being substituted into x. So we get 5 times 0 squared plus 15 times 0 minus 20. Well, these first two terms are 0. So this tells us our y-intercept is negative 20 in this particular question, because if you take these, 0 plus 0 is 0, and 0 minus 20 is negative 20. So when x is 0, y is negative 20. That means we have the coordinate 0 and negative 20, which indeed is a y-intercept. If we look at part C, we're going to equate each of these factors to 0. In the first case, we get x to be 0, and in the second case, we get x to be negative a half. To find the y-intercept, remember you need to put 0 in for x. So in this case, we get 2 times 0 and 2 times 0 plus 1. Well, 2 times 0 is 0, and 0 times anything is still 0. So the y-intercept in this particular question is 0 and 0. Last part, we're going to go back to our graphing calculator to help us look at some things. We're going to graph some things on our calculator, and then we're going to factor some questions and come up with some exact factors for a situation. So what we're going to do is we're going to take our first equation and we're going to graph 3x squared plus 4x minus 7, and we're going to hit graph. Well, that's about what our function looks like. So we're going to sketch approximately what that function looks like. It kind of looks like that, and it keeps going upwards forever, so we put arrows on there. So we've sketched a graph of the function. That's part 1. It says find the zeros of the function as exact values. That means it wants us to use our graphing calculator to actually find the exact coordinates of those x-intercepts. So if you remember, we go second function and trace, and we choose number 2 for 0. Left bound, well, I'm going to move over to the left-hand side here. I'm going to move above my x-intercept and hit enter. Right bound, I'm going to be below my x-intercept and hit enter. And I'm going to see that the x-intercept is negative 2.3 repeating, but that is not an exact value. What that is a decimal. So what we need to do quickly is we need to take our calculator and convert that to a fraction. So we've got negative 2.333. Put as many 3's as you can across the top of the screen and hit enter. then go math and choose the first item, which is fraction. And it's going to tell you that that x-intercept is -7/3. So this x-intercept here is -7/3. Now we're going to find our second x-intercept. And what we're going to do is we're going to go second function and trace. And we're going to choose number 2 for 0. This time our left bound is somewhere underneath the x-intercept. And our right bound is somewhere above the x-intercept. And in this case, it tells us this x-intercept here has an x value of 1. The third thing it wants us to do is write a function in factored form. So if I know x equals -7/3, I'm going to multiply each side by 3 to give me 3x equals -7. I'm going to add 7 to the other side, and one of my factors is 3x plus 7. Here, I'm going to just subtract 1 to the other side and get x minus 1. There is the factored form of this quadratic. You've never worked with a cubic function before, but that shouldn't prevent us from graphing it and getting an equation. So if we graph 4x to the exponent of 3 minus 7x squared minus 4x plus 7, and we hit graph, we get a graph that looks like that. It in fact has 1, 2, 3 x-intercepts. Kind of looks like that. Now we need to use our calculator to find the 3 x-intercepts that we have in this particular situation. So we're going to use second function and trace, and we're going to choose number 2 for 0. And the left bound in this case is going to be underneath the x-axis. The right bound is going to be above the x-axis. And our first x-intercept on the far left-hand side, this is x equals -1. Our second x-intercept is the one in the middle here. So our left bound is going to be above the x-intercept, and our right bound is going to be beneath it. And it tells us this second x-intercept in the middle here is at 1. Now if we find our third x-intercept, tells us it's 1.75. Well, 1.75 is our x-intercept, but remember it wants the x-intercept as an exact value. So if we go 1.75 math fraction, tells us that's 7/4. Now, to write the equation of this particular function, what we need to do is we need to write a factor for each one of these things, but we also need to start our equation with a 4 because our leading coefficient needs to be 4. X equals -1 becomes x plus 1 as a factor. X equals 1 becomes x minus 1 as a factor. And if we solve x equals 7/4, we're going to get 4x minus 7 as our third factor. So there's our equation in factored form. And if you don't believe that this equation is correct, you can actually go in and you can actually graph this particular function on your calculator and see that, in fact, whoops, I missed the 4. Let's see. Oh no, I'm wrong. This shouldn't have a 4 in front of it. These are just our factors right there because the 4 is actually included in this particular factor right there. So we don't need that 4. In fact, this is our equation. And when I go in and graph x minus 1, x plus 1, and 4x minus 7, I do indeed get the same graph that I got before. So in that case, by doing the graph, I actually checked to see did I get the same graph, and I didn't, so I was able to go back and fix an error that was there. So there we have it.